Okay, hello students here. This is back to 2.3 and this lesson is about working with events. The last video, I think I went through all the definition or the main features or the main um, learning objective, that is what is the complement of an event we did. Then also I try to show what is the intersection of events and also the union. So I will continue with problem number, I think the last time that I did was example number 3. This example number 2, let me just walk through because they are asking one more question. That's why I the same example I would like to walk through again to get an idea, even though this problem. Okay, so this question is so back in the class, I remember you guys were really understanding all the concepts. So now I'm gonna go quickly on this. So this is example number 2. I think it is example number 2. Uh, yeah. So you can check your paper. So this problem, you as you can pause the video and also do it by yourself, right? So please do this by yourself. In an experiment, the rolling of a die, find the intersection of. See this E and E intersection T. What does that E basically means? It gives you E is an event that the number rolled is even. So what are the possibles that the number that shows up here can be 2 and 4 and 6. So these are the even numbers. So you have three options here, or we call it three outcomes, right? So here I will just write N of E is, in this case, you can see there are three possibilities. So N is 3. Then also I would like to write what are the other options that could be here. That means that sample space means all other options are 1, 2, 3, 4, and 5 and 6. These are all possible outcomes when you roll a die. So the number of outcomes is, and you can see there are 6 of them, 1, 2, 3, 4, 5, 6. So that's 6. So this is important information. This is important information. And the reason I'm trying to show this is, let's see later on, but then there is another event which says T, the number rolled is greater than T. So that means this number greater than 2 could be, so which are the options that 2 is 3, 4, 5, and 6. So that means this will be 2, 3, sorry, greater than 2 will be no 2, right? So let me take this 2 off and it will be 3, 4, 5, and 6. Okay, so there are 4 of them. You can clearly see that means this is T. T is an event where the number is greater than 2. So how many outcomes are there? And you can see there are altogether 4 outcomes. Okay, now the question is we have to create another, we are going to create, what is this? This means E intersection T basically means what is common in both. It means it means E and T. So that's what it means. And then E and T means it should be both, not only even number. So this means besides even, it should be also greater than 2. So which are the even number here? So it means among this one, this piece, and among this, which are even. And you can see the common ones. I will use a different color here to show that green color. You can see there is a 4 here and there is a 4. This 4 is common. So that's what this means. Intersection basically means common. And also there is a 6 is common. So there is a 6. So it is 4 and 6. That's it. These are the only two. So that means how many are there in E and so E and T, that means there are altogether 2. And not only this, besides, we can also find the probability of this. So, so let's write down. So here we want to know what is the probability of this happening, that means E and T. And you can see probability E and T is number of outcomes for E and T divide by all possible outcome. That means all this, right? So this will be this 2 which is there down, 2 out of 6, 2 out of 6, which could be written as 1/3, and you're done. So I'm going to keep this 2 out of 6 because just to show that uh, uh, this probability is because 6 is the all total. So all possible outcomes, 2 out of 6. My question is can we write probability of E and T is directly probability of E multiplied by. So does that really help? Let's just a quick observation. What does this work out? And you can see probability of getting a even number is 3 because there are 3 of them, and you can see these are the 3, so 3 out of 6 times, and the probability that it is greater than is 4 out of 6. So this is 4 out of 6. Okay, and you can clearly see this will be, let me write it here. So 3 times 4 is 12. 3 times 4 is 12. 12 out of 30. I'll keep 6 and 6 as it is. So we can cross out this, and this 6 divide this 2 times. So this answer becomes, and you can see the answer becomes 2 out of 6. So you get the same answer. See, so this answer and 2 out of 6. So what did we learn from here? What I'm trying to say here is, let me clean this off. What is this means is probability of even intersection and a number that is greater than 2, and we can see we got it 2 out of 6, and which can be written also as probability of E times probability of T, and this is, it is called, these two events, the reason to have the same common, not always this can happen. So these two are same is because they are called E, E and T. E and T are, so you will see, are called, they are called independent events. Now, what is the meaning of independent event? So independent events, so not only independent events, we can also call, since E and T, because the question was only asked what are the outcomes. The outcomes of 4 and 6. And see, it's not empty. There is something there in between, right? Not empty. So what that basically means also, E and T, they are both disjoint also. They are called disjoint. They are also called mutually exclusive. So these are the vocabulary, mutually exclusive. So as in when we work a lot of problems, you'll understand better what's going on here. And in another way to show is there are two even numbers. See, I can use Venn diagram to show. So what are the outcomes that are common is 4 and 6. So this is like even and this is like T. So the number which are greater than, so this could be 5 here. Okay. And I can put also here 3 here, 3. So you can see 3, these are the numbers which are bigger than 4. And even number is 2 will be right here. And what about 1? 1 will be outside. So 1 is neither even nor it is greater than 2. It is less than. It is less than 2. So anyway, just to have a visual understanding what's going on here. Also to know what is the meaning of independent events and what is the meaning of mutually exclusive events. So when you say mutually exclusive events is when the intersection, there is some number, see, it's not empty. And what is the meaning of independent? When probability of this is same as multiplying like this. Not always this is going to happen, this works, but sometimes we call it dependent. So what is dependent means not always E and T. So not always E and T will be not equal to probability of E times. So this does not work all the times. So when it does not work, we call dependent event. So there is a separate formula for that. So that will say dependent. This is dependent event. Let's go to the next problem. Okay. Now, this is the same question. This is example number 2.2 on your paper. Check it out. Suppose a fair die is fair. Find the probability that the number rolled is both even and greater. So we already worked this out. We already found this answer in the previous problem. With this, that event even and greater than and greater than this, we've seen that it was 2 out of 6. Okay, you can check. Now there is another question is, second question is, suppose the die has been loaded. Now what is the meaning of loaded? It's not it's not, when you roll a die, there is not, what is that called? It's not very, it's not kind of not biased. I mean, it can be one side could be a little heavier there like this. So one side could be have a same number could be repeated because of the biased. It is weighted on one side maybe. That's why. And the question is, so that's why they gave us something like this. Probability of 1 is given to is 1 over 12. And the probability of 6 is given when you roll a die. So this is 1 out of 12. So so this is given 3 out of 12. So this is 3 out of 12. Okay. Now, uh, and the remaining 4 outcomes are equally likely. So that means they have the same probability. I can create a table like this and write down. Let's see, outcomes. Okay, outcomes and probabilities. That means probability of 1, 2, 3, 4, 5, and 6. Let's see. The 1 is given as 1 out of 12, and 2 is we don't know. So these are the one they have equal probability. So because we don't know, I'll put it like x here. So let's put it like an x. We don't know what is the probability. The sixth one is given is 3 out of 12, right? So by rule, probab so so if these are the outcomes, probability of 1, so probability of 1 plus probability of 2 plus probability of 3, each individual probabilities always add up to a probability of 5 plus probability of 6 is always 1. Okay, that's because sample space n of s, remember, whatever this is, maybe some number n, then each individual number could be probabilities of the event. Like, for example, if you really get confused, let me just give an example of tossing a coin. If you toss a coin, when you toss a coin, head or tail can occur, right? So the sample space is head and tail. Okay, and then you can also see if I try to write probability of each one of them, what is the probability that it's going to be head? What is the probability it's going to be tail? And you can see what's going on is head is only one, so it is 1 out of 2, plus tail is also only once, 1 out of 2, and it adds to it, a half plus half is 1. See, so eventually the total probability of all the individual events from the sample space, these are called individual events. Okay, I think let me clean this. Okay, something is happening here. So don't mind, please. You can always fast forward. If you understand, you don't have to wait for all explanation. I'm just trying to show how this. So this probability was 1 over 12. So let me write this is 1 over 12. And this four of them, they all are x, x, x. Remember I said x, x, and x. There are four of them. So I can write 1 plus 4x. So they all will be 4x. So this will be 4x. And plus this one is right here, which is 3 out of 12, right? Equals the one, this one. Now this 112 and 312, they together will be 412. So this will be 412 plus 4x. This is 412. This is 4 equals 1. Hmm. So that means you can also write this as 4 over 12 If 4 divides 12, which is 1 over 3, or we will leave it like that. So I'm going to subtract 4 over 12. So subtract 4 over 12 both sides. So you do that. So you subtract to the left and subtract 4 over 12. So you get, so this crosses out and you get 4x equals, now there's a 12 in the denominator, so I multiply 12 and 12. So that will become 12 minus 4 over 12. So this will be 4x. 4x becomes 8 over 12. Okay. And then we have to divide both sides by, so you divide by 4. I don't have enough room. So you're dividing for both sides. And you can see 4 and 8 divides. 4 divides 8. How many times? 2. So it comes 2 out of 12. So your probability will be 2 out of 12 here. So this takes care of what is each one of this. So this is 2 by 12, 2 by 12, 2 by 12, 2 by 12. But this is 1 by 12. These are 3 of them. So let me go back and clean this up and let's write down the last answer. So the last answer is, find the probability that the number rolled is both even. So the probability of the so so let's write down what is ENT. First of all, we need to know what is ENT means. ENT, it means that there are only 4 and 6, right? So that means this we can write probability of 4 plus probability of 6. If we go back, we have already seen that the x that we figured out was 2 out of 12, now which also represent all 4 of them. It's like not only is probability of 2, it is also probability of 3, it is also probability of 4, and it is also probability of 5. So probability of 4 is also 2 over 12. So this is 2 over 12, and this is 3 over 12. So the answer becomes, the common denominator is 12, and you add this 2. 2 plus 3 is 5, and that's the answer. So this is how, and if you really want to know, visual understanding of this, I have to draw like this, 12 of them. See, 4, 5, 6, 7, 8, 9, 10, 11, 12, let's say. Okay. And then I need to know the what shows up here, right? So this piece, this piece. So what number shows up, and what that means the so it's like a dice is rolled 12 times, and then you see what is showing up here, right? What numbers show up? So there are 12. So here, when a die is rolled 12 times, it's seen that. So the one only, see this, the one which you see is only one. So that means this one is only ones. So maybe showing 1 here. And what is the meaning of this 6? 6 is appearing 3. So this is 3, 3, 3. So the number that shows 6 is, sorry. Yeah. So what I will show is, so this 1 is here. And then the rest of them, they show up 2 times. You can see the 2 out of, it means the 2 is showing up 2 times, 3 is showing 2 times, 4 is showing 2 times, 5 is showing 5. That's all it means. So when you do this, so what are the chances that it is even and intersection? It 4 even is 2, 4, 6, right? And greater than 2 is 3, 4, 5, 6, and both together even, and this is 4, 6. So that's what the understanding of visuals to know why it is this answer. So this is even, and this is, so we have 1, 4, and 6. So 4 is, these are 2, and these are 3. So altogether 2 plus 3 is 5. I hope that makes sense. So little confusing, but in anyways, I just wanted to share the visual understanding how it works. But there's a lot of algebra that you saw, and you may got confused with that piece. Okay, let me go to the next one. So I already explained what is the meaning of mutually exclusive events in this. So what is mutually exclusive events? When the probability, if you if you have probability is zero, it means what does this basically means? Uh, if A and B are two events and you don't see anything there, this number of outcomes for this is zero. In other words, if this is by Venn diagram, you see the students who like mathematics, they go for tutoring, and some students go for maths, chemistry, and none of the students have common, means both. So either they take this one only, or they take only chemistry. So there's nothing common here. So such cases we say they are mutually exclusive. So I hope that makes sense here. What is the meaning of? Another word they use also is disjoint. Disjoint events means they don't have anything common. Okay, it could be sometimes we there is overlapping of math students and chemistry students going for tutoring. So maths and chemistry, and you see there are some students who could be taking both chemistry, and there may be three students going for maths and chemistry. And there are some students taking here like this mathematics but not chemistry. So this means that mathematics but not chemistry, and this piece will be only chemistry but not. Anyway, so that's the understanding. So let's take straight away go to the problem. So example number 4, determine if the events are mutually exclusive. Okay, so first of all, two things: either you say A intersection B, there's nothing common. It means it's like empty set. Okay, we can also call this this, or we can write probability of A and B, because it is empty, the answer here, there's nothing here, right? So it is like zero out of whatever the number, the sample space. So eventually this is zero. So now when you randomly select a card from a deck of cards, so these are the cards, okay? These are the 52 cards, okay? And when you pull out, let D be event that you select a diamond. So D is diamond, card is a diamond card. And another one is R is a event. This is a red card. Okay. So these are the two events. So the question is, first question is asking us, are these two events, are these mutually exclusive? So how do we know that whether they are mutually exclusive or not? Uh, is there any overlapping? That means when you pick a card from here, can a card be both diamond and also the card could be red card? And you can clearly see all diamond cards themselves are also red cards, right? So every diamond is a red card. So what is a diamond is this one. So this one is a red card. So this is a diamond card. So these two events, the D, when you pick a card, it's going to be a diamond card. Of course, there are 13 of them. So that event and the second one, it is a red card. So if you see both this red card, there are 26 of them. How you get 26? Because there are 13 plus and there are hearts also. See, so there are 13 here and a 13 there. That means this is an example of these are not mutually mu- mutually exclusive, because there are some cards which are it means there are cards which are common for both. That means, in other words, in this spatial example, we see in this example, something nice is happening is about subset. It means D, we say every card, every diamond card. mm, So every diamond card is a subset of red. That means D is you put like a U shape, but like this, horizontal U shape of R. And then when you do this, you will see later on that D intersection R is the D itself. It means all cards of every diamond card is inside the red card. Because the red card itself, there are 26 of them, 26 red cards. And in this card itself, there are all those diamond cards. See, all those. If you want to take the intersection of this, it is this one. This is the common for both the red card as well as diamond card. So this is what you're going to learn later on. And the next question is D is an event that it is diamond, and B, so this time it changes. The question is one more. So D is a diamond, but the second one says, B is an event. So the B, what is B stands for? It means it is the event that you select a black card. Card is black. Now the question is, what is first of all, we want to notice D and B. Which are the cards that are both diamond as well as card is black? Can a card be both diamond card and black card? No. So this is empty. So there are no cards which are both black and diamond. So this is an empty. So that means here probability. So the question is, this is mutually exclusive. So why they are mutually exclusive? There's nothing common. See, they are empty. Their intersection is an empty. It means it cannot happen that both, when you draw a card, the card cannot be a diamond card as well as how can it be both a diamond card? Because diamond cards are red cards, right? And you're saying B is black card. So a black card cannot be a red card. So there is nothing common. And this is mutually exclusive. The second one is Q. Q is says in event that you select a queen. So this is card is a queen. Card is queen. Or queen card, right? And R is the event you select a red card. Card is red. So and you can see by just this example that queen. So these queens, there are different queens, right? There are queen. So you can have two black queens and you can have two red queens. See? Okay, so and then red card, these are altogether 26 red cards. And you can see among this will be a common one. So there are two cards which are common, two common cards. And that's why this event that you see, uh, when you pick a card, are these two events mutually exclusive? It means can a queen card, are there common cards for when you pull a card, it is a queen, and can it be also a red card? And yes, and you can see there are two cards which are queens and which are also red cards. So then that's why these are not mutually exclusive. So there is common, no, not mutually exclusive. So I hope that. So this is the one union of events basically means You can see from this Venn diagram itself, there are two circles here. This is set A for event A, and the other one is event B. And what is the meaning of A? This time we are using this one, see, A union B. What does this basically means? Either the card. So when you draw a card, let's say either the card is A or the card is B, or it can be both also. That's what this A union B, or another way to write is A or B. So there is a addition rule to find this probability. So what is that addition rule? Is probability of A union B is probability of A plus probability of B, and then you have to subtract some cards which are common A and B. So when you talk about probability of A in this example, this means probability, it means this whole thing, and then I'm using a different color, maybe orange, green. So this is probability, and then you can see that when you are doing A or B, that means I can't just only add this. So this is not just adding this, because there is one part which is common. See, this is repeated, and you can see this piece is repeated for both A and B, and because it is repeated for both any, so you have to subtract. So that's why the subtract. So it is, you take away those ones and get that answer. So we'll take problem direct, and that is example number 5. In an experiment rolling a single die, so this is a die, find the union of events. So there are two events here, E. So what is E basically means? It is 2, 4, and 6. This is the event E. And what is this? Greater than 2. So we did this problem earlier, but I'm writing again 4, 5, 6. But this time they are asking you what is, so this is T and this is E. The question is find the union of this. What is that union means? E union T. Another way to say is E and T. E or T, not E, or is U or T. So either, so you're going to write something here. So whatever that you're going to write here, it has to either come from this first one, or it has to come from here, or it can come from both, both, both of this. So what we do is, it's like putting all this and this together. So if I write the first one is 2, 4, and 6, and you also put the other one, which is 3, 4, 5, 6. The only thing is if there is any repetition, then you can say 6 and 4 are repeated. So we write it only once. So this answer is E or T is 2, 3, 4, 5, and 6. So there are 5 of them. So that's the probability. So the question is only asking you is find the union of events. So this is the union of event. We are done. But if they had to ask her what is the probability of E union T, of course you by just looking at it, you know the answer. It is 5 out of 6. But can we use the formula and get it also? Addition rule of probability says if you have like this, you just write down the probability of the first plus probability of the second, and then you subtract probability of whatever is common. See, and so this even there are 3 of them, so you can see there are 3. So this is 3 out of 6, and greater than 2 there are 4 options, so 4 out of 6, and the ones that are common are 4 and 6. So this 4 and this 4, 6 common, so there are 2 out of 6. See, and now we can, the denominator is the same, put the 6 exactly the same, and you put this 3 plus 4 minus 2, and you can get here it is, you get 3 plus 5 is 7, 7 minus 2 divided by 6, you get 5 out of 6, and that's it. Did we not get 5 out of 6? So this does help you how to go about um, using addition rule of probability. So what are we doing is using addition rule of probability. Okay, let's take another example. So here I already showed the formula. You can see here, this is the formula that you see clearly, whatever. So two ways to write. Let's take directly problem example number 6. So suppose we flip a coin. So there are two things and roll a die. So two parts. So you flip a coin and you roll a die. Okay. Now I wanted to know the probability of getting head. So you want to get head in the first. That means when you have. So this is how it is. So let's start. So the when you roll a toss, when you toss a coin, you have option H and D, right? So there are two options. When you roll a die, you have one. It could be 1, 2, 3, 4, 5, and 6. So what are our options? So the question is asking probability. To find the probability of getting head on the coin, so there are two parts, or 6 on the die. So what that means is we have to see what are the outcomes. What are all possible? So let's find the sample space. All possible outcomes, options. So it could be in the beginning. Let's see if the first one was head. So let's see if the first one was head, then the die, the number that shows up could be 1. If the first one is head, it could be the number 2, or it could be first head 3. And I think you know what I'm trying to do. So these are all options. If the first one is head, so you get, so there are 6 of them. Or it could be tail first. So tail first and 1 in the second, tail 2, tail then 3, tail and then 4, tail and then 5, tail and then 6. So how many are there? Okay, so this is a sample space, and the number of how many are all possible options, and you can see there are 12 of them. So what do we do now? Next is the question is let let's call A is, so A is uh, getting ahead. The first one on the coin, head shows up. Okay, and B, it is 6 on the, so 6 shows up. It means second one. So instead of, so our question is what is the probability of A? That means the first one is head, or the second one is 6 shows up, right? Now, so let's write down. Now, by formula, it is probability of A, the first one, plus probability of the B, plus, and then you have to subtract, minus probability of A and B. What does that basically means? Yeah, both the first one shows head and this one shows. So we want to know when can this happen? Both head and tail. Now this is probability of A. So now look up in this all this entire sample space. Which are the ones the head is showing first? And you can see. So I'm gonna use maybe orange color, pink color. So you can see one, the head is first, head is first, so head first. That's what, so there are 6 of them. So this means 6 out of 12. Now I'm going to use green, maybe red color. I'm taking time. If you understand, you can go fast. Uh, Second one is B, 6 shows up. Now, which are the places that 6 is showing up? And you can see 6 is right here, and 6 is, so there are 2 places going to show 2 out of 12. Now minus, and which are the ones that shows both head first? So here it says both. So A and B means head first, and 6 second. And you can see this, the only option is the black color. There's only one. So 1 out of 12. So Now all of them denominators are 12, so you common denominator. And since they both, all of them have the same denominator, you can write down the numerators exactly the same. Like this. And 6 plus 2 is 8, and 8 minus 1 is 7 over 2. And you're done. So this is how. So one is your visuals that you see here. See, you can clearly see that is the probability the head is first, plus B is probability the 6 is second, and you can see it is 2, and then you have to subtract the 1. So when you are trying to figure out probability of A, it means this H6 is repeated twice. So when you are writing the first one, you already counted this, and then we are doing this again. It is counted. See this piece. So and that's why, because this counted twice, you have to subtract 1 here. So I hope that helps. Thank you. Okay. Example number 7 shows two fair dice are drawn, are thrown. So that means this is this one dice, and this is the second dice, right? So we have seen in the class how to write all possible options. Now this could be any of 1, 2, 3, 4, 5, 6, 5, 6, and this could be any again out of 1, 2, 3, 4, 5, 6. And you can see there are all together. When what is the sample space basically means, let me write it right here, means a big sample space, which would be 1 and 1, 1 and 2, 3, and 1. There are 6. So if the first one is 1, there are 6. There are 6 like this. And I'm going to write for 4 because it's talking about 4 here. That's why. 4 and 1 could be 4 and 2. So these are. Okay. And likewise, we start with 5, then 6. I'm not writing 1 and, sorry, 2 and 3. So I picked up only these two. The reason is, and because if there is 4, it could be 2 and 4. It could be 2 and 3 and 4. It could be 5 and 4. It could be 6 and 4. So I'm just trying to show you all of. In between, I skipped this. Basically, what it's asking you, when you throw these two dice, what are the probabilities? P. So the probability that the first one is saying that both dice shows 4. So both are 4. First one 4. Both are. What that basically means, the first one is first 4, and the second also is 4. Okay. Now you can count here which are the options that you guys can see. So this one, there is a 4. Okay, so for the first part, there's only one place there is, you can see there is only one first 4, and this is 4. So this is only one. That means out of this, there are 36. So these are 6, 6, 6, 6, like this. So there are 36 outcomes here, which are 36, and out of 36, this will be, so your sample space is this, whatever I wrote here, but the number of possible outcomes are 36. And out of this, the red one that I showed here, see, this is the only one. So this is the only red one, 4, 4. See, so it is only 1 out of 36. And you're done. That's the first one. But the second one is a little tricky. At least one die shows 4. So what does this means is probability. That's how you can do in two ways. Probability at least one die is 4. So what it means is at least means it is also so if I call, so I can say, let's call the A as the first A is first is 4. That means the first one showing up over here, and B is an event. The second one is 4. Okay. So the question is asking at least one die shows up means it is the union from B, the probability of A union B. So this is the question is asked to us. It means at least means either it has to be either the first number should be so either the first number is 4, or if that's not the case, the second number is 4. Or it can be both 4 also. So that's what the understanding here. So So at least one die. So there are two ways you can do. One is by just looking at it, and you can see, you can count this. In this case, there are 6 options. See, so the first one, there are 4 is appearing 6 times, and here also you can see 6. There is a there 4 is right here also. Okay, because this is already counted, right? And then you have 4. There are 2 here. So all together, this 6 plus this 3 and plus the bottom 2, they all add up to 11. So the answer becomes 11 out of. So one is by visual to see, you can see it's happening, and the answer is done. And another approach would be we will use addition rule of probability. And what is the addition rule of probability is? So let me write this right here and say, okay, so is, I'm going to write it right here. Addition rule of probability says probability of A union B is probability of A plus probability of B minus probability of A and B. See? So it means probability of A, the first one is 4. So P is, what are the probability that the first is 4 is, you can see these are all 6, right? 6 of them. So that's 6 out of 12. Then the second one is that the second one is 4. So in this case, the second one is 4 is this one. Again, there are 6 of them. So these are 6 out of 12. And the next is what are both. It should be first one is 4 and the second one also 3. So this is the piece which is, see this piece is, so there's only one. So this is 1 out of 12. I think I made a mistake. This should be 36. And this is 1 out of 36. So this will be, everything is out of 36. So everything is out of 36. Let's write this back here. So everything out of, this is out of 36, this is out of 36, this also is out of 36. That means the common denominator is this. So it is 6 plus 6 minus 1. And you can see 12 minus 1. And 12 minus 1 is 11 minus 36. And you're done. Okay. I hope I made sense. As I said, you don't have to watch the whole video. You can, whatever you understand, and you just go and fast forward, or maybe do. But I'm just trying to show all options possible. So the next question: suppose we draw a card. One card is drawn from deck of cards, and there are two parts here. What is the probability that we get a queen? Or remember, when you say or means like this. So we can call A is the first one, that the uh, card is queen, okay, and B is card is, or instead directly say, let's call it direct. Of course, you can write and then king like this, and organize, and then say, okay, what is the probability that the card is queen? Either the card is queen, okay, so in words you can write, or the card is king. See, so or we can write this as probability of that card is A. That means I put it like A, right? A union B. So that means you can write it as probability of A because of the formula addition rule of probability says B, and then A and B, so that means these are the cards that are both queen and the king. Now, what is the probability that the card, when the card is drawn from the 52 cards, because there are 50, and you pull a card, so what are the chances that probability that the card is going to be a queen? So first of all, it is a ratio, right? And there are 52 cards, so 52. But then you're saying like, how many queens are there in the whole thing? You see, there are four queens, two red, two black. So there are four options. So it becomes 4 out of 52. Then how many kings are there? This means B is kings, right? So again, there are four kings. So two black and two red. So that become 4 out of. But how many cards are, that means I have to write another probability that a card is queen and a king. The question is, can a card be king and a queen? No, right? Queen is separate, king is separate. So these are disjoint or mutually exclusive. Okay, there's nothing common. It means A and B, there's nothing common. It means it is like empty. It's like you put a circle and put a bar like this. So it means nothing is there. So there are no cards. It means there is zero. So that's how you write. This whole thing will become zero. So 52 is common denominator and you get 8 by 12. You can also divide this by 4, both up and down by 4. And you can get 2 out of 13. So we'll keep it like this. And even if you write this is okay. The next question is asking us that what are the problems that we get a red card or a king card. So let's do that. So this one is talking about B. So the B is already I said, let's call this is red. So let's say R stands for red card. Card is red. Card is red. Okay. It means you are saying probability that it is a red card, red, or so you can write in words also, king. So by formula, probability is a red card, red, plus probability of the card is king, plus minus probability the card is both red and red. Oh God. Now, so if Rebecca watches this, she will laugh now because I'm making mistake there, right, Rebecca? So this is red and king, both. Okay. Now, how many red cards are there? So when you pick, these are the cards, right? So when you draw a card, you have out of 52, there are how many cards are red? You can see there are 26 red cards. Then how many cards are king? So out of 52, there are 4 king cards minus. And how many cards are both? So both red and king, right? They should be both red and king. And you can see I'm using the color. So there are 2 cards. So these cards which are red color and they are also king. So this king. So it could be a diamond card, this a diamond, okay, and a heart like this. So king of heart. So this doesn't look like a diamond, right? Uh, So king of diamonds, and this doesn't look even like a heart and a heart, king hearts, and a card is heart. So these are the 2 cards that are both red cards, and because you can see the color that I showed you. They are both red cards, okay, and they are both king cards. I'm taking a little time here to show so they can comprehend what I'm talking about. So this is both king. So that's why there are 2 cards. It's 2 out of 52. And I think now you already know what I'm doing. You can see you can just add this 26 plus 30. Uh, Let me clean this off here and write down maybe here. I'm taking my time. You can fast forward. You can just go use your mouse, cursor, go forward. I'm just making a room here to write down. And this will be equal, so that is 26 plus 4 minus 2 divided by 52. So 26 plus this is 30 minus 2. And if you subtract, okay, 28 divided by, you can still reduce this. You can see 4 goes, so we can divide both by 4. Okay, and 4 divides 28 is 7 times, and 4 divides 52, 13. So 7 over 32. And 4. Okay, what does this basically means is in 8.2, a tutoring service specializes in preparing adults for high school equivalence tests among the students seeking help. That means they go for tutoring from service. So the 63% need mathematics. Okay, that by every 100 students is like 63 students, and there are some students 34% is this, and there are some students who are both. These are both mathematics need help in maths as well as and English both. Right? So we can let's write down two events. So question is, what is the percentage of students who need help in either mathematics or English? That means let us call two events. First one, let's call this A is students uh, needs help or a student who is going for English tutoring. So I will say maths tutor. So maths tutoring. Student is maths. And B is the student who is going for English. That means what is A and B? This basically means a student who goes for both maths maths and also he goes for tutoring or he's taking assistant to take help for English. Both it is. Now what did they give us is you can see 63% need help. That means probability. What is probability if you choose a student that this student is going to need? That's what that is. 63% means 63 out of 100. It means it is 0.63. Now, what is the meaning of B? Probability that if you select randomly a student that he's asking for English, and you can see there is 34%, and 34% means 34 out of 100. That is 0.34. And they also give you 20% in both. That means this piece probability of a student when if you pick a student that he needs help in both maths and English. So that is given to you is 27%. So the 27% basically means 27. So that means it's going to be 0.7. So we are going to use the addition rule. And what is the addition rule says? Addition rule says probability of A union B is probability of A plus probability of B and A and B, like you see. So you already know the answers. So what is the students who need either? So the word either is very important. Either means either he is mathematics or English. It means first one probability that student selected is he may be taking maths help is 0.63. Then the second one is here 0.34, and then you subtract this one, which is a red color, 0.27. And you can put this on the calculator. 3 plus 4 is 7, and 3 and 6 is 9, 0.97. And you subtract this 0.27, and you end up getting 70, 0.70. And what is 0.70 basically means? You multiply 10 up down, it means it is 70 out of 100. It means it is 70%. You're done. So how do we understand these visuals? Maybe I would like to show the visuals also here. Let me make a room here. Using Venn diagram, we can understand this. Assume that there are 100 students. So I'll make a, these are all 100 students. These are 100 students. And out of these 100 students, there are blue I'll use for, there are 63 students. So these are 63 students who take mathematics, maths. So there are 63. And those who are taking English, like this. This is English, right? So English are, there are 34. So these are 34 students. And there are students who are 20. Now, if you look at this, this means 27 students are both. I'm using red color for this. So there are 27 students here. These students are both in the English as well as, that means we want to know what about this part. This, how do we figure out only, let's see, if I want to know this pink color only, that means students who take only maths class. That means from 63, if you take away 27, so if I take away 63 and you take away 27, and you'll see you get this becomes 5, that becomes 13, this will be 6. So from 5 you take 2, you get 30. So almost 36 students are taking only maths class. So this is the this part. This is the only maths. Yeah, this is math. And what about students who take only English? That means here 34. I have to take away 27 because we want to know only this space. So if I take 27 here, we get this will be 2. Take 1 and look at 17. This will be 70. See? And then now I have to see what is the probability that when you select a student, either he is from the first one, means I have to, you can see these are 36, these are 27, and these are 7. You put them together, you can see they are becoming 70 here. And that's what we got, see 70. So that's the visual. And that means there are 30 students who do not, they don't take any assistance from maths and English, because from 100, if you take 70, you get 30 remaining. So they don't know, they don't go anywhere. So I hope that makes sense. So this was your Venn diagram. So 36, 27 is both, and this is 17 and 30 outside. So that's the understanding of, beautiful understanding of Venn diagram. Using Venn diagram, it helps to know the visuals. Let's move to the next part. If you see the next example here, is also example number 9. So let me show. So example number 9. So volunteers for a disaster relief effort are classified. So you can see, you please read this. What basically it means in short, I'm gonna write. So you are given a table. By just looking at the table, you can see, depending on a person. Let's say this is one person. That this person can be good at construction, or maybe he is good at education, or maybe he is good in what is M? Medicine. See, like he knows a lot of. So a person can have those qualities, like he can be good at. Or there are some person who are also good at, maybe they can speak one. So that's what this piece means. S basically means speaks a single language. That means he knows single language, only one language. Or that could be another person who can speak two languages. He can so that T basically means two languages. Now, what is the question is, I want you to read this question and comprehend what is given. So in this example, let me make a new directly. So even if they give you a table, that means I'll add one more uh, row and one more column just to show that how many how many volunteers could be they have. Now what is C means they are good in construction, and you can see there are 12 with, who know one language. There is one who knows two languages. So 12 plus 1 is 13 like this. That means this 13 stands for a number of persons who are good in construction. So the next one is who are good in education. That means this will be 4 plus 3 is 0, 7. See? And this will be 6 plus 2 is 8. And then and if you add these three, that means single language, 12 plus 4 and 6 becomes 22. And this will be 1 plus 3 plus 2 is 5, 6. Okay. And together you can see both ways. This will be 28 total. That means out of 20. Now we go directly. So that's what this explains to you. A volunteer is selected at random, meaning each one has an equal chance. That means this is like not biased. Find the chance that their specialty is medicine and they speak two more languages. So now this is what the question is. So the question is probability is. So what does this means? Two speaks it means medicine, and two or more means this TC and T. So all you do is go back here and check. So we'll go right here and see medicine. So go to the row of medicine, so this one, and also go to the column of two more languages. So that means this one. You're going this way. So all the way you go here and there you go. So two persons, they both, two person have, they are good in medicine, and also they have both. That means it is 2 out of 28. Okay, so simple. And you can write this answer as you want. Let's see whether they want you to keep it, yeah, or you can reduce by dividing by 1 and 14. The second question is, so let me clean this, then we make a room for other questions. I hope, mhm. So I hope I'm not going too slow, right? I'm really going too slow. I know why I'm going. So this video is done only for you guys to help, okay? So I hope it's, so either when you pick a student, the specialty is medicine. Now see this. This one says it. Now what's the difference with the first one? Or union T. So this is the difference between the first one and the second one. So how do we do this? Now one thing is you can directly write. I will show you how. So the medicine there are all together. Okay. So this together is medicine. This together is 8. See, 8 are in medicine. And of course, if I this two also will be those who speak language. Now this two is already put in this 8, right? So we don't. So it is like 8. So it's going to be 8, and this 4, which is 12. Okay. So so the answer is going to be directly. So this answer is 12 out of 20. But I'm going to use the other formula. And what is that formula is addition rule of probability. What is that addition rule of probability says is if you have this way, then you write it as probability of the first, that means student is good in medicine, probability the person is good in two languages, and you have to take away probability that is both is good in medicine as well as he speaks two more languages. Now, medicine is right here. So this number here, this is this part. This is that 8 out of 28 plus what is this? PE means this total. This total is 6 right here. So this is 6 out of 28. And you have to take away the one that are common. And you can see the common is this one. So this one is both because it is medicine as well as the knows two languages. So that means there are two of them. So you go this way, you reach here. You go this way, you reach here. So there are two. So that is 2 out of 28. All have 20 at the bottom, so write only once. And then write the numerator exactly the same. So you get 8 plus 6 is 14. And 14 minus 2, you get, you're done. If you want to reduce, we can also write it 4 divide, 4 goes 3 times, 3 out of 7 also. And the last question is, what are the chances if a person is selected? He is other than medicine. What is the meaning of this other than medicine? So probability means other than medicine means it is probability of medicine complements it. Not, in other words, uh, probability is not medicine. So this is a different way to write not medicine. So we can use complement rule. What is complement is probability of uh, complement like this. It means person is not knowing medicine is same as 1 minus, this is by formula. What is formula? Complement rule. Complement rule says it is probability of medicine. Now 1 minus medicine, so how many are in medicine? You can see there are 8 of them. So this is 8 out of 12, and you can multiply to have the same common denominator, multiply 12 here, and you can see it 12 minus 8 out of 12 gives you 4 out of 12, which is 1/3. Or you may also could have done this, sorry, it is out of, I'm sorry, this will be 8 out of 28. I'm sorry here, this will be 8 out of 20. So this is 28 and 28. And if you subtract here, let me clean this up again. So that piece is, I don't know why I wrote that. So this is 1 minus, uh, and again this part, right? This is 8 out of 28. Because there is a 28, I'm going to multiply both by 28 divided by 28. So you have a common denominator 28, and the numerators are written exactly the same, 28 minus 8, and you get 20 out of 28, which can you still reduce it if we divide by 4 5 times. You could also write in, if you put on the calculator, you get it as 0.57. Sorry, 0. You can see I'm tired now, which is 71%. So I hope, so we have a lot of problems like this for practice. These are examples, but then when you come to exercise, you have a lot of problems to do. So the exercise begins here. So these are all easy question now. Now this is the sample space. What is a complement? Remember what is the meaning of this is. So A is given to you. So what is the question? What is the complement of A? Now all you do is complement is set. So the outcomes that you're going to write, they should not be here. So other than this, so these are the sample space. So you have to, because there's A, D, E, A, D, E. So you cut off A, cut off D, and cut off E. What is left is B and C. That's all it is asking you. And then let's see the next one is what are the problem? What is the B? So this question is not probability. It is just the event. So just the event A complement. So if I want to write B complement, it means we have to write down. You take off B, C, D, E. So I take off B, C, D, and E. So what is left is only A. That's it. You're done. And the last one is what is this means what is complement of this? That means you have to write something. S basically means when you say S, it's all of this, right? It is A, B, C, D, E. So that means you want to write something here. That means from this, uh, other than this, but you can see which are the outcomes from here which are missing here. That's how it is. So from here, what is not missing in the sense. So you have to take off this A, B, C, D. So if there's A, B, so everything is the same. So A is gone, B is gone, C is gone. So there's nothing left. So this outcome is a blank. So complement of C is just blank. That's the understanding of. Another example to write what is the complement of this, right? This time this is T and U, right? So which are the outcomes in this sample space? That means R complement. So what does this means? R complement. It means outcomes that are over here, but they should not be here. That's what this means. That means you take off the T and U. So what are you left is R, S, and V, and you're done, right? Then what about the next one? I'll use green color. T is R, right? So T complement will be the outcomes that should not be R. Okay, so I have to take off R. So what are you left with is S, T, U, and V. And the last one is C is empty set. So C is says empty set, and let's call this as C only, which is an empty set, right? So that means there's nothing here. So you don't say anything. So that means you have to write. So you have to write. You have to write outcomes of this that are not here. Okay. So C complement means you have to write something that should not be here. And you can say there's nothing here. That means all this will come back here. R, S, T, U, and V. Okay. Question number Question number three is so you are given a sample space of tossing three coins. These are the three coins, head, tail. Okay. So all options are shown. And two events are defined to you. Each is says at least one head is observed. So and M is more heads than tails. So let's write down the first part is list outcome that comprise of each. So we can write right here H. I'm gonna write right here H. So what is H is what are the outcome that at least one head. Okay. So that means the first one is correct H H H. Here also there is H H H T. This one also H T H. This one is T H. At least one means it can have one head, two head, or three head. That's what it means. This one is H T T. Then T T H T, and then T T H. Now I cannot write the last one. So these are seven of them. Can you see? So all together, I'll just put a seven. So there are seven there. Now the next one, more heads than tails. So which are the heads that can be more head means two heads. So you can see the very first one is correct. Okay, so let me use a different color. So this is yes. Here also there are two heads. That means heads are more than tail. This also is correct. Head, tail, head. This also is correct. Tail, head, head. Okay, this. So there are four. And do you see any other one? No. And you can see here there are two tails. So tails are more. Here also tails are more. These are tails are more. So these are the four. So this piece is four of them. So this is M. So if I want, let's write this again on top because those are the main ones. So your M stands for this. M stands for H H H H H H T H T H and T H H. So the same thing that you see is the first four, right? So these are all together four. Now the questions is asking from this information. So what did we do? Is we did the first question. We've done the first question is done. The second question is you have to list out what is common for H and M. So what we're gonna do is the B part. I'm writing here B part. So there is H and M. So which are the ones that are common? And you can see the common ones are the same that you see here. Okay. These are the ones which are right here. So these are the common ones. So all of them. That means it is H, 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 T, T, sorry, H, T, H, and so that takes care of this. What is the meaning of this? H, either either it is at least one head. So it's like putting together all of them. And if you put this together, it means you're putting the whole this piece. Okay. So you're putting the first one, everything it stays the same. Like H, H, T. So I'm writing the H part. So if you understand good and T, H, H, then we have H, T, 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 H, T, and T, T, H. You can see there are 1, 2, 3, 4, 5, 6, 7. Correct? Now you have to also put, because there is a union means you put this and this together. But these numbers are these pieces, these four are already there. They are the same here. You don't have to repeat. So you already get the same thing. So these are 7 again. That's what this HUM. And we have HC. So what is HC? HC is complement. So you have to write something here which are other than H. Now H is this is the H part. So this is the H. So what is the other than H means what is missing there is the tail, tail, tail. See. So what is missing is tail, tail, and tail. So when you talk about tail, tail means there is no head. So this is the only one tail, tail, and tail. And you're done. That's all you do. Okay. The next question is, so we finished with this. Assuming all outcomes are equal. So now we have to write probability. So we already have these three things. All they're asking you is the C part. What is the C part? Probability of H and M. So the sample space is all of them. So these are all of them. Out of A, there are 8 of them, and which H and M means there are four here. This is that there are 4 of them. So 1, 2. The second one is what is the probability of H U M? That means union, and you can see there are union is this one. This is the union. So the same color that I put here. This is the union, which is the same as which is actually the same as H also in this case. So this is 7 out of 8. And the last one is probability of this. So probability of H complement is there is only one here. So 1 out of 8 in it. And the question is asked, the fourth question is whether or not determine whether this, it means I think here he's saying not P, it should be HC. So the question is HC and M, are they mutually exclusive? Now, how do we know something is exclusive means do they have anything is common? Now, let me use different color for this. Okay, too much of stuff here. So use maybe, do you see anything common in H complement? Now H complement is this is H complement. And what is M? M is, sorry, M is here. So if you see this, do you see anything common here? We can see there's nothing common here. Okay, this is separate. So there's nothing common. So that means here, um, so the last question I'm putting here. So the last question I'm putting is H complement and M, there's nothing. So this is like empty, it's like blank, there's nothing common. And because there's nothing common, we say, because there is nothing common, we can say that complement of this and M are